MCQ 25 will shift our focus towards the structure of eye. So eye itself has two segments, one of them being accommodation. This itself will help the eye to look at objects that are bright or objects that are dim and make the suitable adjustments so that we can have sufficient light intensity on the fovea of the eye. Now, the components that are involved in accommodation will involve the circular muscle, radial muscles, which both of them are part of this combined structure known as the iris, and they ultimately play a part in trying to modify the diameter of the pupil. Now, on the other hand, here we could also be looking at another form of corrective mechanism known as focusing. Focusing will be for objects that are far and for objects that are near. Now, the structure of the eyes that's involved will be the suspensory ligament, the ciliary body, or which some might refer to that as the ciliary muscles. They are synonymous, they are the same. And together, their main effect here is to modify the convexity of lens. And the convexity of lens will then give rise to the difference in your focal length, which again is to trying to focus the light on the fovea of the retina. So two main things here: accommodation, ultimately trying to modify the diameter of the pupil, and focusing, ultimately trying to affect the focal length of the lens by altering its convexity. Now, with that itself, if we look back into the question, the factor for consideration is on a near object, so focusing will be the direction that we're looking at here and not accommodation. So we are given ciliary body, lens, as well as suspensory ligament. So for a near object itself, the lens will modify from a regular size lens, and as a modification, we'll have the lens actually becomes shorter and thicker, and this actually increases its convexity. So the reason why this was actually done for was because initially in a near distance object, the light rays, it enters the eye in a diverging manner. And if, let's say, the fovea is represented over with this cone-like structure, the light rays actually focus behind the fovea. And because of this, the vision is considered to be quite blurred. But in the adjustment post-focusing for a near-distance object, the light similarly is coming in a diverging manner. We do have our fovea, but through the change of the lens convexity into one that has a higher convexity, we are actually decreasing the focal length. And with the decrease in the focal length, I'm going to draw the new path of the light in pink color. It will focus nicely on the fovea of the retina. So to do so itself, we will expect our suspensory ligament to slacken. And you can think of suspensory and ciliary muscles to be kind of opposite. If the suspensory ligament slacken, which is a little bit like relaxed, that must have meant that the ciliary body actually contract. The ciliary body actually contract. So again, tracking it back here, suspensory ligament will slacken. And for the case of the ciliary body, although we don't have the word contract or relax, but contraction here is again synonymous with the length becoming shorter. Just put a slash here, contract. So ultimately this causes, again, the lens to become more convex, decreasing the focal length so that we can focus on the fovea. The answer for MCQ 25 is D.